Terpenes are a very large group of natural chemicals with great importance for the flavor industry, as they are constituents of most of the essential oils. They can be divided into the monoterpenes, which are C10 compounds, the sesquiterpene, which are C15 molecules, diterpenes with 20 carbon atoms, the triterpenes with 30 atoms, and the C40 tetraterpenoids, to which the carotenoids belong. Biosynthetically, they are formed from isoprene units by either the mevalonic acid pathway or the alternative MEP or non-mevalonic pathway. Due to the increasing number of whole genome sequences from plants and the progress in metabolic engineering and synthetic biology, research in the biotechnological production of terpene molecules is increasing over the years. Within the monoterpenes are a number of well-known flavor molecules like L-menthol, the peppermint flavor, R-carvone, the flavor of spearmint, while S-carvone has the typical caraway flavor. D-limonene is the typical flavor of orange peels. All these terpenes have in common that they can be cheaply isolated from plant oils, so there is no need for a biotechnological process. But there are other monoterpenes which are not so abundant, where biotechnological processes are of interest. These are, for example, valensin and nootcatone. About these commercial processes for these flavor molecules we will hear from Georg Lenzen from Isobionics. The sesquiterpenes have a great importance also for the fragrance industry, as some very important compounds are available only in limited amounts. An example is patchouli alcohol or patchoulol from the patchouli oil out of the dried leaves of a patchouli herb. An alternative biotechnological route has been developed by Amyris and it's commercialized as Clearwood by Firmenich. Amyris was also able to integrate into a recombinant yeast strain which had a high FPP production capacity, a single multifunctional sesquiterpene synthase. This is the first example of a biotechnological production of an essential oil, as the process does not result only in patchoulol, but into a range of compounds similar to the compounds in the essential oils. Unfortunately, Firmenich was not willing to present this process in this MOOC. Alpha-humulane is another example. It is an important flavor out of hop, which is responsible for the bitterness of beer. By cloning and expression of an alpha-humulane synthase in a recombinant E. coli strain, which possesses a mevalonate pathway, it is possible to obtain alpha-humulane. Currently, the product yields about 60 milligrams per liter are too low to compete with the extraction from the hop. There are also research activities for other sesquiterpenes, like the components of sandalwood or agarwood oil, which are very expensive, but the main applications of these oils are in the fragrance area. Due to the molecular weight of the diterpenes, there are no flavor molecules in this group because the molecules are no more volatile. But some of the diterpenes are used as cosmetic ingredients of fragrances, like carnosic acid or carnosol in rosemary extract or cis-abienol. In the group of triterpenes, especially ambrein has to be mentioned. This is the triterpene alcohol that is the chief constituent of ambergris, a secretion from the digestive system of sperm whale, and a precursor for the very expensive fragrance ambroxid, which is used since ancient times. Even if there are chemical syntheses for ambroxid, a biotechnological process is of great interest. Based on a recombinant Pichia pastoris, the group of Pichler from ACIP in Graz has developed a whole cell process for the production of plus ambrein. The carotenes are examples of the tetraterpenoids. These are the precursors of a number of smaller flavor molecules like alpha and beta-ionone, beta-damascenone, or the iones. Alpha-ionone is the most expensive one out of this group. It has a violet and raspberry flavor. As there are nearly 20 biosynthetic steps, the construction of a recombinant production strain is very challenging. An academic group from Singapore has constructed an E. coli strain which produces 480 milligrams of alpha-ionone and about 500 milligrams of beta-ionone. The German company Phytowelt has recently established a commercial biotechnological process for the production of alpha-ionone and is producing it in a large-scale fermentation. They produce epsilon carotene, which is then cleaved into 2 molecules of alpha-ionone. So as you can see, the terpenes and the other products thereof are a large field where more compounds will be produced biotechnologically in future.